Alright, boys and girls, welcome to our very first video lesson in Chapter 8, 8-1, our lesson on an overview of sequences and series. Okay, a sequence is a set of numbers often defined by an algebraic rule. Okay, just so you know, sequences can be infinite or finite. Infinite means they go on forever, and finite means they come to an end, so there's a set number of terms. The terms of the sequence are of a sub n are a sub 1, that's the first term, a sub 2, a sub 3, etc. If we look at the first sequence right here, a sub n equals 4n minus 1, I could let I'm going to find my first term by letting n equal 1. So if n equals 1, a sub 1 is going to equal 4 times n, which is 1, minus 1, which equals 3. 4 times 1, 4, minus 1, 3. A sub 2 would be 4 times 2, minus 1, which is 8 minus 1 equals 7. A sub 2, etc., would be 4 times 2. A sub 3 would be 4 times 3 minus 1, which is 12 minus 1, which is 11. A sub 4 would equal 4 times 4, 16, minus 1, which is 15. We can see we're adding 4 to each previous term. I got 3, 7, 11, 15. The next term would be 19, etc. Sequences can be arithmetic, such as the last one where we're adding the same number each time. In this case, we're adding 3 each time, so it's 1, 4, 7, 10. 10 plus 3 is 13, plus 3 again would be 16, etc. They can be geometric, where I'm multiplying by a number each time. In this case, a sub 1 is 2, 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128, etc. The next term would be 128 times 4, which don't tell me. I think that would be 512. A sequence can also be a power sequence. In this case, this is 1 squared, 2 squared, 3 squared, 4 squared. Our next term would be 5 squared, etc. Sequences can also be defined recursively. A recursive sequence is a sequence defined by one or more of the previous terms. The most famous recursive sequence is the Fibonacci sequence, which is 1, 1, 2, 3, 5, 8, 13, 21. What we're doing is we're adding the previous 2. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. The next term right here would be 34 because it would be 13 plus 21 is 34. The rule for this can be written when we define a recursive sequence. But first of all, we always need to start with the first term. So a sub 1 is equal to 1. In this case, I'm also going to write a sub 2. A sub 2 is 1 as well. And now what we're going to do is we're going to write the rule. So a sub k is equal to the two previous terms added up. So that's going to be a sub k minus 2 plus a sub k minus 1. In other words, what we're doing here is we're taking our next term is going to be the second previous term plus the previous term. Okay, another math operation you need to know is something called factorials. N factorial, notice it's n exclamation point. It's not just n, it's n factorial and exclamation point. Factorials are defined this way. N factorial is 1 times 2 times 3 times 4 all the way up to n minus 1 times n. So what we do is we add up all the integers starting with 1. We multiply all the integers starting with 1. So 0 factorial, just by definition, is 1. 1 factorial is equal to 1. 2 factorial is equal to 1 times 2, which is 2. Let me get my pen. 3 factorial is 1 times 2 times 3, which equals 1 times 2 times 3 is 6. 4 factorial is going to be 1 times 2 times 3 times 4, which is Again, 3 factorial times 4, which is going to be 24. 5 factorial, we'll do that over here, is going to be 1 times 2 times 3 times 4 times 5, which is 24 times 5, which is 120. 6 factorial is going to be 120 times 6, or 1 times 2 times 3 times 4 times 5 times 6, which is 720, etc. You guys tell me, what is 7 factorial and what is 8 factorial? In class, we're going to show you how to do this on the calc as well. A series is the sum of the terms of a sequence. In other words, what we're going to do is we're going to take our sequence and add up all of the terms to get our series. A finite series is called a partial sum. In an infinite series, that's where we add up all the terms of an infinite sequence, that may or may not be defined. If the series is defined, it comes to an exact number, we call that convergent. And if a series adds up to infinity, we call that divergent. That says divergent, and that equals infinity. Boom. Okay, we can write a series in summation or sigma notation. So this funny symbol here, this is a Greek letter sigma. It looks like an E, but it's actually a Greek S. We start with our first term, we end with our last term, and what that means is the series of a sub I is going to be a sub 1 plus a sub 2 plus a sub 3 all the way up to the last term, n, a sub n. So if we have a series such as this, where we're going to have 5 terms. We start with our first term, end with our 5th term, and the rule is 2i plus 1. My first term, of course, is going to be 2 times 1 plus 1, which equals 3. Our second term is going to be 2 times 2 plus 1, which equals 5. Our third term is going to be 2 times 3 plus 1, which equals 7. So our terms are 3 plus 5 plus 7. Our next term is going to be 9, and our 5th term, our last term, is going to be 11. If I add those up, this sum, or this series, this summation, is going to be 3 plus 5 is 8, plus 7, 15, plus 9, 24, plus 11 is 35. So this equals 35. I will go through this with you in class, but we can do sequences and series on the calc. I will also go through this with you in class, but we can do factorials on the calculator as well. But this is in your notes, so we can do this. You will be responsible for knowing how to do this on the calc as well. Okay, let's do some problemas. This first one, what are the first 5 terms of the series right here? A sub n equals 4 and minus 7. So as we know, a sub 1 is equal to 4 times 1 minus 7, which is 4 minus 7 is neg 3. Our second term, a sub 2, is going to equal 4 times 2 minus 7, which is 8 minus 7, or 1. A sub 3 is equal to 4 times 3 minus 7. 12 minus 7 is 5. You may have already noticed that we're adding 4 each time. Negative 3 plus 4 is 1. 1 plus 4 is 5. 5 plus 4 is equal to 9. That's going to be a sub 4. And a sub 5 is 9 plus 4, which is 13. And we can double check that. A sub 5 is going to equal 4 times 5 minus 7. 20 minus 7 is 13. Hey, hey. We should also ask ourselves, is the series arithmetic, geometric, or neither? In this case, we're arithmetic because we're adding 4 each time. We're adding the same thing each time. Okay, in this one, we're going to find the first 5 terms. Once again, a sub 1 is going to equal negative 1 raised to the 1 minus 1 is 0. In other words, I'm going to replace my n with 1 times 1 times 1 minus 1 is 0. which equals now, negative 1 to the 0 is positive 1, but 1 times 0 is 0, so this equals 0. That's our first term. Our second term is going to be a sub 2, which is now negative 1 raised to the 2 minus 1, which is 1, times 2 times 2 minus 1, which is 1, and that equals now, negative 1 to the first is neg 1, 2 times 1 is 2, so that's neg 2. Our third term, a sub 3, is going to equal negative 1 raised to the, again, 3 minus 1, which of course is 2, times n, which is 3, times n minus 1 is 3 minus 1, which is 2. And this equals now negative 1 to the second power is positive 1, and then 3 times 2 is 6, so we have positive 6. Our fourth term is going to be negative 1 raised to the 4 minus 1, which is 3, times n minus 1, which is 3. This now, of course, negative 1 to the third is negative, and then 4 times 3 is 12. Maybe we're seeing a pattern. We're alternating. Well, the first one was 0, but then we go neg, pos, neg. The fourth term is going to be positive, and we're okay, and I would like you guys to figure out the fifth term, a sub 5, is equal to what? Okay, let's figure out a rule for the following sequence. A sub 1 is 0, a sub 2 is 3, a sub 3 is 8, a sub 4 is 15, a sub 5 is 24. Do we see a pattern? Maybe you see that a sub 1 is 1 squared minus 1, which is 0. A sub 2 is 2 squared, 4, minus 1, which is 3. A sub 3 is 3 squared, 9, minus 1, which is 8. So our rule is going to be, whoop, I need my pen. A sub n is going to equal n squared minus 1. Always ask yourself, too, ag or n, is this arithmetic? No, we're not adding the same thing. Is it geometric? No, we're not multiplying by the same thing to get to the next term. This is a neither. We're going to call this a power series. Okay, in this guy, we're going to find the first 5 terms of a sequence that's defined recursively. Notice that we are given our a sub 1 in a recursive sequence. You must start with at least the first term. So a sub 1 is 15. And now the rule is a sub k plus 1. So the next term is going to equal the previous term plus 3. So if a sub 1 is 15, let me get my pen, a sub 2 is going to be a sub 1, which is 15, plus 3, which is 18. A sub 3 is going to equal 18 plus 3, which is 21. A sub quattro is 21 plus 3, which is 24. And last but not least, a sub 5 is going to be 24 plus 3, 27. This is an arithmetic sequence defined recursively, though. Okay, what are the first 5 terms of this recursive sequence? This again is going to be arithmetic. We can see that we take, our rule is take our a sub 1. We always got to start with our first term. We take our next term is going to equal the previous term. So a sub k plus 1 is equal to the a sub k term minus 5. So a sub 2 is going to equal, let me get my pen, green. A sub 2 is equal to a sub 1, which is 25, minus 5, which is 20. A sub 3 is going to equal our previous term, 20 minus 5, which is 15. And I think you guys can figure out a sub 4 and a sub 5. Go ahead and have fun. Okay, let's do some factorial work. We're going to figure out what 5 factorial divided by 7 factorial. Remember, 5 factorial means 5 times 4 times 3 times 2 times 1. And that's going to be divided by 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. And you're saying, oh, let me get out my calculator. Nonsense. Notice that the 5's can cancel, the 4's can cancel, the 3's can cancel, so can the 2's and the 1's, and we're left with 1 over 7 times 6, which equals 1 over 42. Okay, our last problem. We're going to find the sum. Again, we're in sigma notation. We can see we're going to have 6 terms because we start with our first term and end at our 6th term. I'm going to let you guys figure out the sum. This is going to be an arithmetic sequence. I'll get you started by just giving you a sub 1. A sub 1 is going to equal 3 times 1 minus 1, which equals 2. You need to find the next 5 terms and add them up. The first 5 people from each class that email me your answer, will get a bonus point on our next test or quiz. That's it, ladies and gents. Have a great day, and we'll see you soon.